Hello, everybody. Today, there we go, fun fish tank in the background. We're going to talk about technology used to study the oceans. Oops, wrong screen. You want that one? Share. Okay, we should all be seeing this now. All right, aquatic technology, some tools used to study aquatic habitats. So there's lots of tools that we're going to go through today to help us study the oceans. We've got research vessels. Commonly, you'll see in front of their name the abbreviation RV. RVs are one of the most critical tools that oceanographers have to better understand ocean ecosystems. They are highly advanced mobile research stations. Think like a scientific laboratory out on the water. They provide stable platforms from which researchers can deploy equipment. Divers can reach the water, underwater vehicles, which we'll talk about next. And they also carry a wide variety of state-of-the-art electronics, computers, navigational, and computer systems. So looking at some of our submersibles, 3 basic types. We're going to look at 2 historical types, and then move on to modern ones. So our first historical submersible is the Bathysphere, developed by William Beebe and Otis Barton. This is a steel ball with a window, and it was connected to the ship by cable. So we can see some of the cables here coming out the top. That provided all their electricity as well as life support like air. It only went vertically. They essentially were dropped off, there we go in the picture, dropped off the edge of the boat and sank to the bottom. This was one of the first deep diving scientific submersibles we had. Here are 2 gentlemen, Beebe and Barton, in 1934 with their Bathyscape. This was the first one ever created. Next, we have the Bathyscape, similar to the Bathysphere, except it was attached to a large float instead of a cable in the ship. So this, can't see here, there's a crane that dropped it off the side of a ship still. Ship is still required. It could move around horizontally. There were some propellers. So some of the deepest diving submersibles ever made. In 1960, the very first trip down to the Marianas Trench, deepest point on our planet, was made in a Bathyscape. Still not roomy. This float was filled originally with gasoline to provide buoyancy, and the scientists are still cramped in a tiny 4.5-foot sphere ball. Now on to our modern deep diving submersibles. These still aren't a whole lot roomier. Most of them hold 2 to 3 people. There are some larger ones that can get about 4. Again, moderate to deep depths, good at horizontal movement. So there's no giant float attached to this now. The compartment for the scientist and the motor is now all a little bit more streamlined. They also have robotic arms, so they can now reach out and grab something and put it in a container to take back up to the surface. In our picture here, we have Alvin. That's one of the arguably the most famous submersible involved in the discovery of the Titanic, as well as hydrothermal vents. If you recall from the TED Talk y'all watched last week, this is one of the submersibles that Dr. Robert Ballard has spent a considerable amount of time on. Some of the advantages of submersibles, again, they're able to reach great depths, and the duration of their dives are quite long. They can be measured in the length of hours. Disadvantages, very expensive, like millions of dollars for one research trip. They all need to have some sort of support vessels and teams with them. Very large, so they're not able to access too many places. When the Alvin discovered the Titanic, it could only go around the outside of the Titanic. There was another tool, which we'll get to, named Jason, that was able to then go inside the Titanic for more pictures. Another way we explore the oceans is through diving, and this is people diving, an advancement over just merely swimming. Originally, come on. My slides are messing up on me. There we go. We had hard hat or helmet diving back in the 1800s. This was invented back in the 1800s. Really good for underwater labor. A lot of bridges and things built at the time would have people in hard hat helmets down there. Not so good for research. It's hard, it's heavy. Again, still required a support team and a vessel. This one here has this tube at the top that would have connected to more hose up to the vessel or on shore to provide, again, life support. All right, we're going to skip this one and go on to our modern scuba, or self-contained underwater breathing apparatus. To Frenchman Jacques Cousteau, he was a scientist and then an engineer, Emil Gannon developed our modern scuba system that delivered compressed air. The air is carried in a very small tank. This allows for lots of freedom of movement and the ability to go lots of places. Some of our advantages of scuba and disadvantages when we compare them back to those submersibles. Scuba is a whole lot less expensive. It's very simple. You don't need a team of people to help you with it. There is still training involved, but far simpler than a submersible. It's portable, it's small, you can go lots of places, you've got more dexterity. When you look at our diver here in this picture, hands are free, very easy to grab things or operate a piece of equipment or a camera. Disadvantages would be the depth. Divers are limited on how deep they can go. Usually it's 40 to 50 meters with a few exceptions. They're also limited on the duration, just getting tired from swimming the whole time, from the cold, losing body heat. There are wetsuits that you can wear to help keep you warmer, but there's still a limit. Most people don't dive for more than an hour or two, as well as water pressure. That's, again, one of the limiting factors with going deep is that water pressure starts to impact your body. All right, another machine that helps us out. ROVs stands for Remotely Operated Vehicle. This is a small unmanned submarine or submersible with propellers, a video camera, and an umbilical cord. So they are attached to the ship. And then this one here, Jason, can actually be attached to Alvin. So it can go down deep and the pilot on Alvin can control it. So when it came to the discovery of the Titanic, Alvin, we can see Jason, we can see the cable here was attached to Alvin and able to go inside those smaller places. These will also sometimes have arms, grabby claws, other tools for collecting data. AUVs, autonomous underwater vehicles. These are untethered, freely swimming robots. They've got a self-contained power system, typically solar powered, and controlled by an attached computer. So this will have a programmed route put into them, so nobody's actively controlling it. And they'll swim around and collect data. These can swim around for longer periods of time, days to weeks, and then be retrieved later at the end of their mission by the research team for then the data to be collected. And these do not tend to have grabby arms, but they're going to have just sensors to measure temperature, pressure, maybe pollution in the water, other dissolved substances in the water, even the motion of the wave action. And a lot of them still have cameras for being able to watch. Highly maneuverable as well, depending on how they're designed. Another key technology that is very common nowadays, GPS or Global Positioning System. This receives signals from satellites, helps you to tell you your location on Earth. Real important for things like the AUVs running on their own to know their location. A ship needs to know where they're at, where they're collecting data. Along with GPS is Geographic Information System, and that's applying data to a map. So over here we have a location, and then the scientists have added the seafloor topography data. A more real life experience with GIS is if you think about the Maps application on your cell phone, where Not only does it tell you where you're at, but it could tell you what restaurant is nearby. That would be an example of GIS, that added layer of information to be able to find restaurants near you. And we have sonar, which stands for sound navigation ranging. This works by sending out pulses of sound waves from a ship. It can be used for a variety of things, from detecting the depth of the ocean to features on the ocean floor, and even helping us find organisms. Another item that we have are buoys. There are several different types of buoys. The yellow one in the picture, this would be a scientific buoy used to collect a wide range of data, including salinity, temperature, winds, and waves. Also can be used for navigation. So here are these red and green ones would be navigational buoys. Ships still need to be able to tell where they're at in the ocean. These buoys might appear to be floating around on the water, and while they are floating on the surface, they are connected. There is a large cable or chain that's not visible in this picture that keeps them in one place. Again, useful for navigational purposes. Others, we have refractometers and hydrometers. These are two different tools used to measure salinity, and hopefully in class you'll have a chance to use these. Thermometers for measuring temperatures. Sometimes it's a plain old normal thermometer that you might have used in class before or have at home. Other times we're using satellites to get temperature data. Another important piece of technology, and satellites can collect data from across the globe. In addition to temperature, they can measure winds, wave heights, how much water is in the atmosphere, which will be important when we get to talk about climate and hurricanes, as well as sea ice features and ocean topography. Some of these are sensitive enough that there's enough change in the water level above a mountain under the ocean that we can see it. Then we have anemometers, which measure wind speed. That's this yellow one here. Secchi discs to measure water clarity. And then a historically important one, the chronometer, prior to GPS, helps you figure out where you were. And then last we have our floaters and drifters. Similar to buoys in that they are on the surface of the water. Our drifters are used to study currents and will drift along, collecting current information and then be recollected after a period of time. These ones can be out there again, days, weeks, even months. Floats also move horizontally with ocean currents, but they're also able to move up and down within the water column to collect data not only in different locations, but different depths. All right. Thank you for joining me. I'll see you later.